When you're framing a roof with rafters in a cathedral ceiling, one tricky area to air seal is right at the top of the beam. Keep in mind, this is typically the highest heated portion of the house, which makes it the positive pressure zone, and this is a very vulnerable area for air leakage from inside the house up into the roof cavity. So we want to make sure we do a good job here of air and vapor sealing between the one side of the roof and the other. So in this case, we'll be applying 6mm poly over the top of the beam to make that transition, and we'll be using some pitch blocks to help support the rafters. So follow along as we set this part of the roof. Typically when I run a strip of poly over a beam, I'll staple down, center the poly on one end and stretch it as far as I can, and then staple the other end, maybe go 10 or 15 feet. And that gives you a nice, straight, wrinkle-free strip of poly. If you try to staple along as you're going, your odds of creating wrinkles go way up. One thing to keep in mind here is that polyethylene sheeting breaks down fairly fast in sunlight, and so you'd want to get this roof covered in probably a few weeks or less. You certainly wouldn't want to leave this out all summer, as it would affect the integrity of the plastic. You can see here that our poly is nice and flat and straight all the way along. That means it'll lay nice and flat against the ceiling. In this case, we were able to do the beam with one piece of poly. In some cases, you may have to do the beam in 2 pieces or 3 pieces or more. You will want to seal with Tremco acoustical sealant between every overlap, particularly under this pitch block, to get a good air seal. Using this pitch block method has a couple of advantages. You get an improved air seal because the pitch block is sandwiching the poly between the top of the beam, and you're protecting that poly when you're dragging rafters over it or walking along here. You're not going to damage it. The point here is how you're going to transition your air and vapor retarder, your 6mm poly, over your ceiling is an engineering decision that needs to be made during the planning phase. Not all roofs may be candidates for a pitch block system like this. If you're in an area that requires a structural anchor to mount to the face of the beam, you may have to rethink this. You may either have to glue the poly to the side of the beam or think of another approach to frame this way. But in general, it's another tool in the toolkit and allows for some pretty significant improvements in air sealing as well as thermal performance. I always feel it's nicer if the beam can be put below the level of the rafters, because then you can put continuous insulation over the top of the roof. If your rafters hit the beam, then you've got solid wood in a roof rather than insulation. Not as good a thermal performance. So now we've completed our roof framing. We've held our rollover blocking about 1.5 inches to 2 inches up from the edge of our beam. The reason we did that is it's given us a nailing space here for a scrap of OSB. You can use plywood or even 1x4s or framing lumber. The point is this scrap hangs over into the ceiling about 3 or 4 inches and gives us a place where we can staple our ceiling poly to. Remember, we want to have continuous support for our acoustical sealants, and so this scrap of plywood or OSB here provides that support. It provides a really good long-term air seal in this vulnerable area. It's cheap, quick, and easy to do. You get a really good performance result. Now that we've just about finished insulating our framed walls here, we're getting close to that point in time where we'll be installing our 6mm polyethylene sheeting, which is our traditional air and vapor retarder that goes on the warm and winter side of our wall. But before we install this sheathing, this is a good time to look at any holes in our exterior walls and make sure that we can air seal those penetrations well. It's easier to do this, generally speaking, before you put the sheeting on the wall. Now this window is a good example because even though they're small, we do have air leakage points everywhere the sill intersects the trimmer. Since we'll be weather sealing this sill anyway, it doesn't take a whole lot of extra effort to detail this part here and air seal this window from the inside as well. There are many ways to detail a windowsill. This is one approach for a wet climate, or for any climate for that matter. In this case, we've taken Tyvek Flex Wrap and we've wrapped it into our sill. But rather than stopping midway into the opening, we've carried it all the way to the warm side because that seals the joints where the sill meets the trimmer. As an aside, I like the Flex Wrap for sills. It's nice because it's a seamless form fit around the corners and it goes in quick and easy. So although it is expensive, it does present a significant labor savings and does a really good job on the sill. We've also pitched this sill down about 1/4 inch, so if any rainwater gets past our window, gravity will allow that water to drain back down and out. There is one place though that we still need to deal with, and that is the joint right here where our sill intersects the trimmer on the edge of the stud on the inside. You could caulk this, you could use red tape. I like to use a thin piece of self-adhering flashing. It's got enough flexibility that I can just wrap it right around that corner and get a really good seal. The idea here is then when the 6mm poly goes on the wall, I can caulk all the way around the window and have a really good air seal. As an alternative to using the straight flashing, if you had a piece of flex wrap, you could also wrap that around the opening. There's lots of ways to do it. Virtually all of the self-adhering flashing membranes we have here are pressure sensitive. That means that the stronger you push, the better your bond will be. I like to use a laminate roller. It's also called a J roller because it puts a lot of pressure on the flashing and gives you a much better bond. One thing to consider if you'll be running your flashing all the way to the warm side is it's great because it air seals the joint here very well, but if the drywall installers will be using rotozip tools to cut out the drywall once it's in place, the tip on that rotozip will probably drag along that last ½ inch or so, and it'll make a mess of your flashing and the tool, and that won't make anybody happy. So if that's the way your drywall will be cut out, you would be better served by holding this flashing back about 3/4 inch. And here in the corners, the drywall installers will have to use a handsaw or some other means to cut out as opposed to the rotozip. It does take a little bit more time, so I figured it's something you'd want to be able to deal with up front rather than dealing with it later when you're in the middle of the process. In addition to air sealing the corners around the window openings, one other detail I attend to is I will locate every penetration in my exterior wall and pack that area out with foam board. In this case, I know that I'm going to have a Toyo oil-fired space heater here, and there's going to be an exhaust pipe that's going to go through somewhere, either in this bay or in this bay. And so if I fill this entire area with foam board, later when I've got my drywall on here, I can just hole saw all the way through the foam board. I'm not getting into fiberglass insulation. I've got a nice hole that I can spray foam and seal really well once my exhaust vent is in place. This works for everything. It works for bathroom vents, it works for HRV ducts, it works for dryer exhausts. I know that I'm going to have an exterior vent here, and so I know that later on I'll be installing my HRV supply duct through there. I'll pack this area out with foam board so it's very easy to hole saw through solid foam later, rather than tearing into plastic sheeting and fiberglass and potentially creating a void inside here. What we have here is a roll of 6 mil thick polyethylene plastic sheeting, commonly called 6 mil poly. This is an industry standard in cold climate construction in the northern climates and in Alaska in particular. This material is used behind the drywall to stop moisture movement into the building assembly during the heating season. Now, when we call this a vapor retarder, what we're referring to is its high impermeability slows down moisture travel by diffusion through the wall assembly from the warm side in wintertime. Now, moisture travel by diffusion refers to water, except water in a gaseous state. And different building materials are going to be more or less permeable to water vapor traveling through it. Drywall here, for instance, is quite permeable to water vapor. And so the idea here is that if you install a layer of 6 mil poly over the studs behind the drywall, it will slow down moisture movement by diffusion into that wall assembly in wintertime. Of greater concern to us, though, is moisture movement via air leakage. We still have the same water vapor, but much greater amounts of that water vapor can travel into our building enclosure via air leakage. So the idea here is this vapor retarder not only has to act as a diffusion barrier, but it also has to act as an air barrier. That means we have to install this 6 mil poly so it's as airtight as we can get it to minimize the amount of water vapor that travels into our building enclosure. In order to do a good job air sealing our vapor retarder, we need to glue it down right here on the subfloor. And this is one mistake that people make, is they will run the acoustical sealant, the caulking, right along the sill plate, but that still leaves this joint open right here. So to get the best possible bond, we need to make sure the subfloor is nice and clean right along the base here. Now with my poly installed in a nice straight line across the top of my wall, I'll start in the middle and I'll work my way down. I'll push in the insulation where it's bulging. I'll check over the studs just to make sure there's no insulation folding over. And then I can start stapling down. Now we don't want to staple all the way to the bottom. We still want to be able to lift here and be able to caulk right along on that subfloor. So we'll hold the staples up 4 to 6 inches. When you're stapling around your windows, try to hold the staples to the outer edge of your framing. The idea here is then when you trim the window poly out of the way, you've got room to slide the nozzle for the caulking gun in there and apply acoustical sealant all the way around. The idea here is to get this poly on nice and flat and straight with a minimum number of staples. I don't saturate the poly with staples. I just put in enough staples, maybe every 16 to 24 inches, as needed to hold this up. Tremco acoustical sealant, that's another industry standard that we use for sealing poly, whether it's poly to poly between joints or sealing poly to wood. It's got excellent long-term adhesion and flexibility, so it's a great choice when it comes to air sealing a vapor retarder. So what I'm concentrating on doing here is installing a nice generous bead right along that joint where the sill plate meets the subfloor. If you've got a barky edge, then just concentrate on running that bead right along the subfloor where the edge of that sill plate would be. Some people will just tape the poly to the sill. I think it takes a little bit of extra effort, but I like the idea of having a really good seal right between the poly and the framing. So I'll run my bead of acoustical sealant all the way around the perimeter. This is a really common mistake that people do all the time, and that is putting the poly, overlapping the poly in an unsupported joint. And usually it runs right across a series of stud bays, just like this, with the poly bedded in. Stapled every so often. Maybe it makes it, maybe it doesn't. Maybe it's got red tape on it, maybe it doesn't. The problem is this is not a fully supported joint. It's only stapled every couple of feet. All this right here, A, it's got some wrinkles in it, but B, there's no guarantee that over time this won't leak air. And so this just helps to illustrate the importance of having a fully backed joint. If you were to do this, you'd be much better served doing it on the double top plate or splitting it right here where we've got a roll of horizontal blocking. But don't do it in the middle of an insulation bay without support. Whether you're using red tape or acoustical sealant, it doesn't yield the same results. The idea here is when everything is done, all your joints will be at inside corners where your ceiling meets the top of your wall, where your wall meets your wall, or where your wall meets your floor. When it's done, you look around and you'll see a continuous bead of acoustical sealant around all those inside corners, creating sort of a picture frame. This is a good case in point here. I can't simply just seal this corner here and stop. I have to bring my acoustical sealant all the way to the outside here where this second overlapping sheet ends. That way my acoustical sealant transitions to here, then my sealing poly can pick up the sealant and continue on. Once again here, this layer of poly carries around the corner about 4 inches. I run that bead around 4 inches so I can tie into my next sheet of poly with continuous acoustical sealant. One place that's often overlooked is areas around beams or other penetrations coming through the walls. Remember, we want to bed that poly securely in acoustical sealant, so you need to have solid backing to support that poly where it's bedded in the sealant. So even though a block wasn't required here for structural reasons, it is required to do a really good job air sealing. And this is a vulnerable area. Remember, we're up at the highest point in our ceiling here. This is the greatest path of air leakage outwards. And if you've ever seen a house on the outside with hoarfrost around the gable end, it's possible that you've got warm, moist air leaking out and water vapors condensing then on the outside and forming that hoarfrost. So it's good to go back before you put the poly on and look at areas like this and make sure that all the way around you've got a place where you can caulk and bed that poly in there fully supported. In order to get my poly to fold properly, I'm going to cut to the inside of my beam very gently. And then I'm going to carry that line straight along the bottom of the beam and out. So now I can securely fold my poly around both sides and I can get in there and caulk that area without making a huge mess. Sometimes people ask whether it's worth going back and taping every one of the staples, and I don't have a good answer here. I can lend some observations. I know that from seeing many blower door tests, whether the staple holes were taped or not, if an excellent job was done sealing the poly to poly with acoustical sealant and sealing all the big holes, you can get some very, very tight houses. On the other hand, if you're the kind of person whose interest is in sealing every hole, no matter how tiny, then you may be inclined to tape the staples. Keep in mind that if you're applying drywall directly over the studs, that's going to compress the poly right over the staple. It will minimize your air leakage, and you also have to remember that each row of studs will get screws in it, so there will be additional holes on top of the ones you've just taped. We're now getting ready to put a layer of poly on one half of our ceiling, and we've done a couple of things up here to make our job easier and better. One is, before we set our rafters, we ran a strip of poly all the way across the top of our beam, so we've got a continuous air and vapor seal over the peak of our roof where it's most critical. The other thing we've done is we've nailed some scraps of OSB here between every rafter bay right on top of our beam. That's given us backing for our acoustical sealant and our poly when we apply it to the ceiling. Oftentimes what happens is people will try to run a bead of acoustical sealant right along the top of the beam here, then fold the ceiling poly up to the corner of the beam and down the side of the beam, and that creates problems with it getting pinched and not sealing properly. So taking a little extra time, throwing in this blocking here can yield a much tighter, better job. As you can see, having a nailer here is doing a really nice job in terms of bedding and supporting my poly. I can staple right through the acoustical sealant into my nailer, so I've got a really good long-term connection. Paying special attention to our air sealing when we're installing our vapor retarder is a critical part of our cold climate construction strategy. Uncontrolled air leakage through holes and other gaps equals heat losses, and it can also equal moisture problems since that air is moving water vapor, and the path in wintertime for that water vapor and air leakage to travel is typically upwards and out into places in the exterior enclosure where we don't want it. The idea here is to build as tight as we can reasonably do and then ventilate mechanically and introduce just enough fresh air to keep the occupants healthy and to control indoor humidity levels.